Broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to the webinar on Redis Enterprise on Kubernetes. I'm Christina Cardoza, News Editor of SC Times. Before we get started, I have a couple of housekeeping announcements. First of all, we will be conducting a live Q&A after today's presentation. If you have any questions at any time during the presentation, you may submit them through the Control Panel's question tab. Secondly, this webinar will be recorded and available on demand through the sctimes.com website in about 24 hours after the event. Here at SC Times, we've been writing about the demand for containers as a development and deployment method. Containers enable software to be packaged into isolated lightweight bundles, and a container orchestration tool like Kubernetes provides the ability to deploy, scale, self-heal, load balance, and roll back. Today's webinar will talk about basic Kubernetes constructs, how you can run 3-pod clustered Redis Enterprise on Kubernetes. Here to discuss this further is Vic Kelkar, Principal Product Manager at Redis Labs. Vic has been in the technology field for most of his career, and in the last few years, he has been focused on distributed computing and container technologies. Now to get things started, I will turn it over to you, Vic.
All right, thank you so much. So good morning, good afternoon, and good evening, everyone. Thanks for joining. Today, we are here to discuss Redis Enterprise running on Kubernetes. So what we want to do initially is kind of talk about basic understanding of Kubernetes and what are the basic constructs of Kubernetes and how you want to go about understanding what a deployment looks like in Kubernetes before we jump into the most interesting part, I think, would be a demo of our running service inside a Kubernetes cluster. So as you see in front of you, the agenda and the flow of today's webinar is going to be, we will walk through the basic primitives of Kubernetes, do an introduction of Kubernetes. Then we will talk a little bit about Redis Enterprise and the advantages it offers. Then towards the end, we will step into a demo portion of this webinar. And finally, we will open it up for questions. So with that, let's dive right in to an introduction to Kubernetes. And let's talk about some of the introductions, like why would you use Kubernetes in the first place? To kind of give you a very good answer is, well, containers are becoming the basic deployment unit these days. It used to be VMs 10 years ago and bare metal 20 years ago, but with the greater adoption of microservices, containers are becoming the basic unit of deployment. So Kubernetes offers you the ability to run a containerized, stateful, and stateless workload. So that's the advantage of the Kubernetes platform itself. It's a container scheduler, but you can run not only stateless as well as stateful workloads on this platform. The whole idea behind Kubernetes, I would say, is to encourage adoption of microservices. So you definitely want to break down your monolithic app and introduce or break it down into smaller microservices, and container platform and container orchestration helps you achieve that goal. So what does Kubernetes do, right? And what is it all about? Basically, the idea behind Kubernetes is it's an open source project, but the main sort of tenets of the Kubernetes project and the Kubernetes platform is it is there to orchestrate containers for you so that app developers can focus on writing and Dockerizing their containers, and the platform itself will provide you with the ability of orchestrating the containers that you have packaged up. The main advantage of Kubernetes is that it also comes with some bells and whistles. So it has basic health checks for the containers you will deploy on the platform. So that comes built in. You don't have to sort of create another application framework to go check your container runtime, whether they're up or not. Kubernetes provides a readiness check and a probe. The Kubernetes also has the ability to do rolling updates. What I mean there is you deploy a particular version of your container, and obviously a month from now you enhance your product that is containerized and you try to deploy it on Kubernetes, and it does a graceful rolling upgrade for you. So there is a zero downtime rolling upgrade capability offered up by the Kubernetes platform. And another good thing is when you talk about Kubernetes, you are also kind of talking about infrastructure as code, and your obviously applications are also containerized. So you can define the desired state in a very declarative manner. So it allows you to specify what you want to do with your containers, how you want to scale it in a declarative YAML or a Helm chart. And finally, when you are talking about microservices, one of the key components of a platform is the ability for the platform to provide a mechanism to do service discovery. And Kubernetes provides that construct and that capability so that when you introduce your service, it is automatically discovered and exposed to other services. So these are the main and primary advantages of the Kubernetes platform itself. So now let's switch tracks a little bit and let's talk about the basic primitives that are available in Kubernetes. Because before we go any deeper into Kubernetes, we want to understand what are the basic abstractions that are provided by Kubernetes. So let's kind of walk through some of the common ones that you may end up using in your deployment. So Kubernetes is made up of many sort of primitives. The first basic one is a node. A node in Kubernetes speak is nothing more than a VM that provides runtime for your containers. Whereas most likely you will hear Kubernetes and Kubernetes pod. Pod is essentially the primitive where you are running a container, one or more containers that are deployed on a single node. So that's very important to, let me reiterate, a pod can have multiple containers inside of it, but one of the best practices might be to have one pod and one container in it. The next primitive is the concept of service. Service is a group of pods that provides network service on a certain pod. So when you write a service for your application, essentially this allows you to quickly scale up your service, which might be backed by a number of pods running on a number of nodes. So using this combination allows you to quickly scale your service that you have deployed on top of the Kubernetes platform. The next one we want to talk about is a deployment. Like I was mentioning in the previous slide, it is a very declarative construct, the Kubernetes platform. So your deployment essentially is a YAML file or a configuration file where you're specifying which version of Docker image should the platform deploy, where should it get the containerized application from, how many instances of the pods do you want, and things of those nature, like what kind of node type do you want to use with your deployment. All that can be described in your deployment. And starting with the Kubernetes 1.8 and above, there was a new concept introduced, or a new primitive that was introduced, and that's essentially stateful sets. Stateful sets allow you to run persistent workloads on the Kubernetes platform. They were introduced in 1.7, but they came out of technology preview in Kubernetes 1.8. And the ability to define each pod with its own unique ID allows the platform to create and maintain persistence for your application that are containerized. Another important primitive that we should talk about is the controller. Controller, like the name suggests, it controls things for you, and that could be your service or your deployment or your stateful set. The whole idea, there are many types of controllers in the Kubernetes ecosystem. The way to think about a controller is essentially it's a loop that reconciles the current state and the desired state. And you can have many types of controllers and multiple levels of controllers, but the whole idea is Kubernetes is providing you with that primitive which you can leverage in your application or in your service. So the next set of primitives that we want to talk about are load balancer. So the Kubernetes itself is cloud agnostic. So having a primitive of load balancer allows you to expose your service through a load balancer. Once you define your load balancer in your deployment, Kubernetes itself will take care of instantiating that load balancer in whatever cloud you are in. In AWS case, it might be an ELB, and Azure has its own construct, so does GCP. But the load balancer itself is an abstraction so that you don't have to worry about how that load balancer is getting implemented in different clouds. Another advantage of Kubernetes is it allows you to have namespaces. The whole idea and concept behind namespaces is it allows you to create multi-tenancy and resource and naming isolation. You can do it by user, you can sort of define it by business unit, or you can define it by project. But by default, the Kubernetes comes with a systems namespace. That's where all the system resources are deployed. And then there's a default namespace where if you don't specify a namespace, it will just get deployed in the default namespace. The whole idea of namespacing is it allows you to create multi-tenancy around using the construct and the primitive of namespace. Like I mentioned earlier, persistent sets and stateful sets came out of technology preview in 1.8. And what it introduced was 2 new primitives which help you with persistence. So the way you get a persistence into your deployed application is through these 2 constructs that I'm going to talk about next. The first one is a persistent volume. This is essentially nothing more than storage that you want to have in your cluster. Now, your cluster could be running on the cloud, it could be running on-prem, and Kubernetes is, I think, doing a pretty good job about abstracting away and having strong APIs for the storage vendors. So when you spin up your Kubernetes in the environment that you want, you have the capability and the flexibility of sort of picking the storage vendor you want, and they have a very strong API against which you can integrate. And this allows you to sort of pick and choose the storage class and the storage needs that you may have. So what is PVC, or persistent volume claim? Well, the idea is in the earlier step, persistent volumes, you're defining storage, and then each application in their deployment will then make a claim for a slice of that storage. That's what persistent volume claim is. So in your deployment YAML, you will say, my application needs 10 gigs of persistent storage from the storage class that has been defined on your Kubernetes cluster. And then the last two I think I want to talk about regarding the Kubernetes primitives are kubectl, or kube control. That's the Kubernetes CLI that comes with default and is what drives all the API interactions against your Kubernetes cluster. Daemon sets is an interesting one. I think I wanted to highlight it a little bit. There are situations where you would want to run either your service or your container or your application on every single node in your Kubernetes cluster. So the way you would go about doing that is you define a daemon set. This makes sure that the Kubernetes scheduler will schedule your container on every single node in the Kubernetes cluster. So there are very particular use cases where you would want to use daemon sets, and we can, based on your user needs and how you want to use your Kubernetes cluster, you will configure the daemon sets appropriately. So these are the primary Kubernetes primitives I wanted to talk about before we dive into Kubernetes and try to do a live demo, because I think I will highlight some of these constructs and primitives, and will show you how we have used them. So before I showed you how we did what we did, I wanted to make sure everybody understood or understands or has an explanation of these primitives. So before we kind of dive into a Kubernetes demo, I wanted to talk about Redis Enterprise a little bit. So let me just kind of introduce you to Redis Enterprise. Redis is open source, NoSQL in-memory database, and Redis Labs is home to the open source Redis. It is the company behind Redis open source project, and Redis Labs has built an additional layer of components and commercial offering on top of the open source Redis. So what are the main attractions for Redis Enterprise? So if you look at Docker Hub, Redis container itself has 630 million downloads. It is the most downloaded database out there from Docker Hub. If you compare it to some of the other database vendors, we are doing extremely well as far as the downloads go, and the developer interest is what is making this happen. So it's an organic growth that is coming in from a grassroots level from the developer community. Redis Enterprise has three big differentiators that I wanted to touch upon. The first differentiator is performance. Redis Labs, the Redis Enterprise product itself, is extremely performant. So if you compare it with the others in the market, you will realize that it has very good performance. I think it promises sub-millisecond performance. Another big advantage of Redis Enterprise and Redis itself is the simplicity of the NoSQL database engine. Essentially, you have the ability to use data structures to use so that you can do things in a most performant way. Some of the basic data structures offered by Redis include strings, sets, sorted sets, and a few others that are listed up here, hashes and lists. And the third biggest advantage of Redis is the ability to extend it. What I mean there is our product has the ability to add modules on top of the basic Redis offering. So if you want to make it a primary database, you will just go ahead and enable some of the modules that are available out there and try to use them for your use case. So we provide 3 or 4 modules that are already in the marketplace, but you're also welcome to write your own module and run it on top of Redis itself. So that is a huge sort of advantage around flexibility because it's a modular approach. Another quick sort of touch point here is about performance. So I talked about like it's highly performant, but if you look at it a little bit closely on the left side, this was a study done by a consulting group. Essentially, we compared 3 to 4 different types of databases and looked at how many requests can it handle versus what is the latency they're experiencing. So if you look at the graph on the left, you can very easily see that Redis is doing pretty well as far as the application requests, the load it can handle, and the latency it has, very low latency. The graph on the right is an interesting graph to kind of bring up because it is talking about the total cost of ownership. Like if you are trying to achieve 1 million writes per second, and you compare them to like competing data technologies or databases out there, Redis does not need a lot of VMs to reach that throughput and to reach that writes. So if you see Cassandra, it will take you the cost to get to 1 million writes per second is about the numbers are there, so I don't want to call them out. But if you look at Redis, it is a very small footprint and it's a very small total cost of ownership, but it still achieves 1 million writes a second. Now Redis can be used in many use cases. I wanted to quickly highlight some of them so that you're aware of the capability of Redis itself. First of all, it's a NoSQL real-time database. I think it's prime and center there. But some of the other use cases worth mentioning, you can use it for e-commerce, you can use it for IoT applications, you can use it for metering, fraud detection. You can also use it for personalization, search, and social apps. But this list of use cases will keep growing, so I just wanted to highlight some of them. If you're not familiar with Redis itself, these are some of the primary use cases. So what does Redis Enterprise bring to the table? So let's talk about that a little bit. What you're seeing in front of you is essentially our typical deployment model. What we have is we have at the bottom layer the data path that is based on Redis. Then what we have done on top of that is we have added an additional layer of functionality by introducing a management path, essentially. So this management path allows you to do proxies, it allows you to do cluster management, and essentially provides you with a very low-level proxy capability. And this, in turn, leads to the ability for Redis Enterprise to provide multi-tenancy in the cluster itself. And another advantage worth mentioning before we move on to the next slide is these nodes are all symmetrical. So what I mean here is when we deploy our 3-node cluster, we are deploying the same identical software or container across our nodes. So this makes it a lot easier to handle failovers because all the functionality exists in every single node of Redis Enterprise. The Redis Enterprise itself is pretty flexible as far as the deployment option goes. We offer 3 basic types of deployment for Redis Enterprise. You can take Redis Enterprise and deploy it in the cloud. We will fully manage it, and you can just ask for the resource that you need, and it's as a service, so you're welcome to use it. It's being supported in multiple clouds. Another option is you can bring it into VPC, your own VPC, but it's still a fully managed Redis database as a service, and it will run on any cloud that you need. The third option for Redis Enterprise is software. So this is your on-prem solution, or if you want to deploy it and run it and manage it yourself, you can do that. Right now it is available in the PCF platform as well, and we have a public AWS AMI published in the marketplace. So it gives you the flexibility of running it in any fashion that you want, which fits your need. And with that, I'm going to take a little bit of a pause and sort of talk about and kind of set the stage for the demo I want to get into with our Redis Enterprise release, which is running on top of Kubernetes. So I just wanted to quickly re-emphasize, that we talked about all those primitives, and I think those primitives are key to our deployment. As we were developing our deployment for the Kubernetes ecosystem, we decided to leverage those primitives in order to make our deployment successful on the Kubernetes ecosystem and the Kubernetes cluster itself. So with that sort of quick introduction or preview before I jump into the demo itself, let me just quickly bring up a terminal window so we can look at the Kubernetes cluster that is running our release. So give me a second. I guess everybody can see the terminal window. I want to make sure. So what I have done here, maybe I'll just increase the font a little bit. There we go. I think what you guys are looking in front of you is a completely deployed Redis Enterprise service that is geared for a Kubernetes cluster. In Kubernetes, I think we touched on a little bit, is there's this concept of a service. So that's what you are seeing. So I'm looking at let me just clear the screen here a little bit so that you only see one input and output. So what I'm doing on this command is essentially I'm querying the Kubernetes cluster, and I am trying to get a list of SVC stands for all the services that are in the Kubernetes. PO is a short form for pods. Deployment is obviously all the deployments on the Kubernetes cluster. And I want a list of all the stateful sets that are on the Kubernetes cluster itself. So I kind of want to walk through this output with you. So the few things I'm going to highlight are essentially the Redis Enterprise components. So the first service you see up top is the Kubernetes cluster service. So I'm not going to really focus on that. But the next one, when you look at SVC/Redis pack, that is the service that we have developed and deployed using some of the primitives we talked about earlier. And if you notice, it has a cluster IP, which is an internal IP to the Kubernetes cluster. And then you have an external IP. So we have exposed some ports. If you will see on the last column, we have 8443 that is being exposed on that external IP. So in a little bit, we will go to that external IP and see what is available on that publicly facing external IP. The next service that you see in the output is the Redis Pack headless service. And the whole idea of the headless service is it helps you with persistence, and it helps you route your application that is being exposed to an appropriate container that is running it. So it's a quick way for the applications that want to access your application to reach it without knowing where that pod or where that Docker image has been scheduled. Another good example here is service. So what you're looking at is, before we started this webinar, I set up a database. And what our deployment does in Kubernetes is once we create a database, we automatically publish your database in this service catalog. And we will step through an example of that in the next 5 minutes. So I'll come back to that construct in a bit, but let me move on and continue down the line. So the next 3 lines that you're looking at is Redis Pack 012. I think those are our symmetric Docker images that I talked about earlier. They're identical in the code base. This is our basic deployment of a 3-node Redis Enterprise cluster. And since we are using persistent sets, they have ordinality to them, which in the future will allow us to do 0 downtime deployments. Another one to quickly sort of touch on is the controller concept I talked about earlier. Controller, if you remember, is nothing more than a loop that helps you go from a desired state or go from a current state to the desired state. So we have written our own controller, which helps us achieve the outcome that we are looking for. And then Redis Enterprise does offer persistence. So we are leveraging the primitive stateful sets to make that happen on the Kubernetes cluster. So I wanted to quickly show you all these constructs and all the resources now that have been used by a successful deployment. I did not want to take too much time during this webinar to go through the steps to set this up, but it is achievable, but I want to focus our efforts in this webinar on a demo. So this is a very basic deployment and the resource consumption you will see on your cluster from a Redis Enterprise perspective. What I want to walk you through next in this demo is I wanted to show you the Redis Enterprise interface and how that interacts with Kubernetes and what changes you will see once we come back to the terminal itself. So before I bring up a browser, again, you will notice that we have an external IP. So I'm going to go there and I'm going to hit a port 8443 that we have exposed on that external IP. So let me quickly switch application windows and bring up the interface. So if you notice, what you're seeing in front of your screen is a web browser. This is the same IP I was talking about earlier. It is an external IP and it is running on 8443. In the get services call, you notice that I had an SD times database I was using to set up this demo. But what I'm going to go and do right now is I'm going to create a new database and we will see what the implications and effects are when we do create a new database. One thing to highlight here is a Redis Enterprise interface is identical. It doesn't matter which deployment model you use, you will see the same exact database. I think I talked about whether you want to run it in cloud or VPC, or you can want to download it as a software and run it yourself. You will get an identical interface to Redis Enterprise. So that's one good advantage there, is of the consistency that you will see between the deployment models. So let's walk through what you will do with Redis Enterprise once you have it up and running, right? So the first thing your application may need is a Redis database. So what I'm going to do is go ahead and create a Redis database here for the demo. Obviously, I'm going to go with the most complex name here. We're going to go with a test, the name of the database. Let's see that we have 32 gigs of memory available for your Redis NoSQL database. For quick demo purposes, I'm going to go with a very small 1 gig database. And then I'm going to say activate. So what it has done is it has created a database for you, and you can see it in the web UI. And then I'm going to bring your attention to the endpoint. Whenever you create a database in Redis Enterprise, you end up with an endpoint that you can hit and bind your application to. So you can get access to that information through this configuration web UI. So the test database that we just created has this endpoint in our cluster, and then it is running on this port. So what I'm going to do now is I'm going to go back to the terminal and see what happened with the same command that I ran previously. So I'm going to run this command. It takes a little bit longer because of my awesome Wi-Fi connection, but let's look at what happened. You will notice in the first set of outputs that now you have something called svc/test. So what our controller has done now is it has automatically published that endpoint with that same exact port in the Kubernetes service catalog. So you don't even have to change your workflow. Essentially, you create the database and it will automatically get published in the Kubernetes service catalog, and you will see the service when you do kubectl get service. So that's the advantage here, is you don't have to go do this discovery yourself. We will quickly expose it and publish it in the Kubernetes service catalog. So that's the quick demo there around what you see around service discovery and what our controller is doing and what capability we are bringing and what kind of integration we are doing with our Redis Enterprise and Kubernetes itself. I think this demo is a little bit on the light side. Is that great? We have created a database, but what about performance of the databases that we have created, right? So if I go back to the databases through the web UI of Redis Enterprise, now you see that, hey, I have an SD times database and the test database I just created 2 minutes ago. Now I could have written a demo application to hit this database, but what I'm going to do now is I'm going to use a tool called Memtier. Memtier is used to measure performance of NoSQL databases. It's something we have written and published. It's available for you to try. So what I'm going to do now is I have a YAML file that describes the benchmark tool. So I'm going to quickly show you what that YAML looks like. It is not terribly complicated. We are essentially creating a deployment. We talked about that primitive before. We're going to give this deployment a name. We're going to call it benchmark. We are going to use a public image. Again, it's available on Docker Hub, Redis Labs. So you're welcome to download it and try it. I have already pre-filled in the database endpoint, the database name. So now let's go back and do this deployment, and let's see. The whole idea of this application is to simulate and create some load on the database we have created. So I'm going to just quickly do kubectl apply, and if I can type, the bench.yaml that I just showed you. So it's, again, internet speed here, so it will take a while, but you will now see that the bench.yaml has deployed a deployment called Redis Benchmark. This deployment itself has one container that I showed you. It's a public image that you can go and play with. So if I do the same set of commands, get pods is what I'm interested in this time. Once the output comes out, you will see that we have a new deployment called Redis-Benchmark, and we have a new pod called Redis Benchmark with a random GUID to identify it. So now this application, which is running inside the Kubernetes, is generating load for the databases that we created earlier. I ended up picking up the first one just for simplicity's sake and make sure that we're not taking up too much time editing a YAML file in VI. So what you are seeing in front of you now is the performance metrics of the Redis Enterprise in Kubernetes. So as you can see, the Mentier application has connected to the SD times DB and is doing reads, writes, and we are now kind of looking in front of you is how many ops per second you are seeing. So it is an extremely good throughput and ops per second of over 900K. And the latency is pretty good, around 3.4 milliseconds. So again, this is the advantage of Redis Enterprise is we offer very high operations per second with very low latency. So I think this is pretty much the demo around how you would connect to Redis Enterprise running inside of Kubernetes. Instead of a demo application, I just ended up using a performance tool, but you can connect your application to the Redis Enterprise service the same way. Only things you need are a couple parameters, and they are available through the web interface, and we automatically publish it in the service catalog of Kubernetes. One final demo I will do here is I will go back to the terminal and let's try to delete the database. So we created a test database earlier. I'm going to come back to the web console, web interface. I'm going to go to the test database. And what I'm going to do now is essentially delete the database through the web UI. So what this is supposed to do is essentially, once I go back to the terminal, I will not see that database in the service output. So instead of doing all of them, I will just focus on the service, because if you notice on this output earlier, there was SD times DB and test. So when I do a get service now, you will not see test because it has been deleted, and the endpoint for that database has automatically been removed by our controller, so that you will not see any stale endpoints or any stale connections. So I think this basically encapsulates all the three features and capabilities that we have introduced in Redis Enterprise, and how you may use Redis Enterprise in Kubernetes. So I think with that, I would like to kind of stop here and remind everybody. I'm going to go back to my slide deck a little bit and kind of refresh what we saw. What I showed you was what the resources and the resource footprint looks like when you deploy Redis Enterprise on Kubernetes. We saw 3 pods running, a service running, a deployment, and a stateful set. You saw me create a database using the web UI. Then we went back to the terminal, and you were able to see that same database endpoint being published in the service catalog. Then we went ahead and connected our benchmark tool to a database. I ended up picking a database I had staged earlier, and we did a performance test on it with very good results of about over 900 K ops per second with just 3.4 millisecond latency. And then finally, I kind of showed you the, like what happens when you delete a database from our web UI, and what is the effect on the service endpoint that is published in the Kubernetes service catalog. So I think these, these are some of the things I wanted to highlight in the demo, which brings us to the next slide. So I think we are continuing this conversation in the near future at RedisConf. So I invite everybody to take advantage of this offer that you see in front of you today. I will be giving another presentation on Kubernetes and what enhancements we are doing to our Kubernetes deployment. So please, take advantage of this registration code that is being offered to all the webinar attendees today, and we can have a more detailed conversation at the RedisConf. So with that, I am going to take a pause and give everybody a chance to ask questions.
Great, thanks, Vic. Yep, so we are now going to open the webinar to any questions. So Vic, what are the advantages of the Redis Enterprise services for Kubernetes over other approaches?
Wow, okay, that's a good question, a tough question, and that's the first question. Okay, let's see if I can do justice. I think the advantages are many. Some of the ones to highlight is Kubernetes Redis Enterprise release allows us to auto bootstrap our cluster. So when you do a Kubernetes scaling activity, you don't have to worry about rejoining the pod. We have done a good job of our controller and the capability of scaling activities so that we can quickly scale up if that's the need of your application or your cluster. So that's one advantage worth mentioning, is auto bootstrapping capability. We are trying to follow best practices in the Kubernetes Redis Enterprise release by leveraging some of the constructs and primitives I talked about. One of them is we are taking advantage of the Kubernetes secrets. So if you want to store any of the licensing information or any of your passwords, we do it by default using Kubernetes secrets. So these are some of the key advantages that we offer over other platforms or systems. Auto bootstrapping, seamless scaling, zero downtime rolling upgrades, and using the native primitives, I would say, are some of the key advantages.
Great. So why did you pick controller versus operator on Kubernetes?
That's a good question as well. So, I think I touched on the controller aspect of it in the primitives discussion. But what I did not talk about is the operator concept. So the way I see it, right now we are focusing on the feature sets that we want to develop, and controller, meets our needs. In the future, we may reconsider that approach. But for everybody's benefit, the difference between a controller and an operator is essentially, I would say, an operator is a superset of a controller. Operator allows you the capability of managing the life cycle of your service, which may be different than the life cycle of another service. So if you have multiple services that you are responsible for and you want to have the ability to control each life cycle of a service differently, then I would say, go with the operator approach. At Redis Enterprise, we only have one service right now with one concern, and we decided to go with the smaller subset because it fits our need. But it could go either way. We might expand into the operator in the future, but for now, it's the controller approach.
Great. So what versions of Kubernetes are supported with Redis Enterprise?
Right, that's a good one. I think I touched on it a little bit earlier. Redis Enterprise does offer persistence. So in order for us to support persistence, I think the minimum requirement is you must have a Kubernetes version 1.8 or above. 1.7 had persistence sets and stateful sets in technology preview mode, but they came out into general availability with version 1.8. So we support version 1.8 and 1.9 in our current release of Redis Enterprise.
Perfect. So can a single K8 cluster be installed on distributed physical sites? And if so, what is a virtual private network to connect the nodes of the cluster?
Right. So I think, you have to take that into account. I think the question is kind of geared around fault domains and the ability to span a single cluster across 2 data centers. And, what is the network topology going to look like? There are a couple approaches there. One is you can try to spread your one single Kubernetes cluster across 2 AZs or 2 data centers. But Kubernetes is with 110 or I think 111, they have it in their roadmap to have a federated Kubernetes approach. What that means is you can run Kubernetes in 2-3 data centers, and all those Kubernetes clusters through a federated approach will be aware of each other and can share resources and authentication schemes. So I think that may address the question you brought up. But if you are thinking about a localized Kubernetes, you will have to introduce some sort of network overlay. And some of them are open source, some of them are closed source. You can think of like Calico and Weave are a couple of the examples the community is leaning towards. So you might want to look into that.
Great, thanks, Vic. I believe that is all the time we have for today. Before we go, I would like to just quickly throw it back to you, Vic, for one final thought or key takeaway to leave our attendees with today.
Sure. I think one of the key takeaways here is, Kubernetes now has persistence, stateful and stateless workloads, and Redis Enterprise is natively integrating it with Kubernetes. So we also offer stateful and stateless capabilities using stateful sets. So I think that would be my summary.
Great, thanks, Vic. And just one last time before we go, can you quickly just go over what the registration is one more time and how our attendees can use the code?
Yeah, absolutely. So, we are happy to let the audience know that we are organizing Redis Conference, Redis Conf. It's coming up in the near future, April 24th through 26th in San Francisco. And I think thanks to this event, you can take advantage of that registration code that you see on the screen. And you can get pretty good discounts on Redis Conf event itself by going to redisconf.com.
Great. Well, thank you, Vic, for a great presentation. Again, that was Vic Kelkar, Principal Product Manager at Redis Labs, and I would like to thank Redis Labs for sponsoring today's webinar, as well as the attendees for joining us today. Until next time, I'm Christina Cardoza with SD Times.